Welcome, everybody. This is Home Performance Essentials. It's not called Home Energy Essentials because we're going to be talking about much more important stuff than just energy. And I'll get into that in a minute. My name is Corbett Lunsford. I'm the technical director of a company called Green Dream Group. We have a couple different divisions. We have the Chicago Home Performance Division where we do diagnostics on a daily basis out in the field in the Chicago area. We work on existing homes. We work on new home consulting. We work on small commercial stuff. So we use infrared, which is the lens that we're going to look at home performance and the way that the system works and how to evaluate it through the lens of infrared. And hopefully that makes this very essential building science exploration a little bit more colorful and fun. I also am a trainer with a company called Building Performance Workshop. That's our other division. We do advanced trainings for people who are already certified and BPI certification classes. I also am a ResNet trainer, and I run an organization called the Illinois Association of Energy Raters. It's a HERS providership and a trade association in the state of Illinois. So it's a bunch of the HERS raters and BPI professionals in Illinois. So that's a little bit about me. I did not used to do this. Before I did this, I was a musician. I worked with audio systems and signal flow and things like that. And so I come at it from I want to be able to think creatively. I think that's really one of the fun parts of this job. I think that we all, most of us at least, I would say 90% or so, have second careers that we're in right now. We all used to do something else, and I think that it's really interesting to try and find where that melding of the past life and the current life comes in. Real quick, show of hands, how many people are already using infrared? It seems like, oh good, now you guys changed seats and now it's all over the room. How many people would like to be using infrared? One guy back there, all right, great. How many people are using home performance analysis in your daily work every day? Okay, how many people are trying to incorporate home performance analysis into what you're already doing? Fantastic. Okay, great. So hopefully this is a very broad spectrum course, but I talk really fast, so I have to warn you about that. If I lose anybody, feel free to just interject, jump in, and ask a question. But I will try to get really, really advanced while at the same time covering the basics about everything and how it really interlocks. So first off, I start every single presentation that I ever do for homeowners, for professionals this way, right? Obviously, every building is a system. How many people agree? Everybody raises your hands. The building is a system. That's one of the fundamental tenets. The problem is that, number one, homeowners and consumers are not just encouraged, but are trained by companies and by us in the contracting industry and by the federal government and by utility programs to think in terms of just little products and components that they can buy off the shelf, plug into their house, and get a rebate for, right? So that's one of the issues. The second issue is that they like thinking that way, right? Americans do not prefer complex solutions for things. So the reality is, of course, much more complicated than that. It's all about the installation and how all the interdependencies and the interactions work within the building envelope and within the different systems inside the building. That is a complicated thing. That's more like what we were talking about in this conference that was put on in Chicago, the Better Buildings Conference in Schaumburg last month. We talked about the idea of magic buckshot instead of a magic bullet. Of course, the homeowner that you're going to talk to wants the magic bullet. So you have to dress up this very complicated system in the form of a little magic pill that you can give them, they can buy and say, oh, that was delicious, thank you very much. So, just real quick, the three main steps to any meaningful analysis of basically anything in life, right, is first inspection, second diagnostics, third recommendations. Don't start making recommendations until you have run the diagnostics. As Joe Stiebrick says, you don't get the dough unless you do the show, right? So you don't just get to walk up to the house, which I'm sure a lot of you in this room can do, and just walk up and say, oh, I can tell you exactly what the problem with that house is. $600, please. Right? You have to pull out your blower doors. You got to pull out all your scientific equipment. Sometimes you are really surprised, right, by the results. Also, inspect first, because if you don't know what it is that you're supposed to be analyzing, using a bunch of really expensive tools on it makes absolutely no sense, because you have no way of interpreting the data. One of the reasons that no robot is ever going to be able to do your job is that robots can't do qualitative analyses on the very complicated interactions of things in life, right? So it takes somebody like you, a highly paid professional, right? Everybody raise your hands. Yes, good. Okay, you should be charging more. To be able to do the analysis that really is going to result in a meaningful opportunity for improvement being taken advantage of and fixed in that person's home. Okay, so home performance aspects. There are 4 of them. The way that I teach them, they break down into from least important to most important. Number 1, heat flow. Okay, everybody thinks they get heat flow. Hardly anybody actually gets heat flow, right? Somebody was telling me a story about being in a room full of heating engineers, and he says, we all agree that heat rises, right? And everybody says, oh yeah, raises their hand. It's like, we just got that really wrong. That's very, very simple. So the thermodynamic principles are pretty complicated, actually, and even people who are, boiler installers for 40 years don't necessarily understand all of the aspects of radiation, convection, conduction. When you study it in just a real simple science class, it sounds really boring. When you start actually implementing this stuff with what La Liberté was talking about a little while ago, and in his master class, which I hope that some of you went to, it's really, really complicated. And you got a radiant barrier in there somewhere, you got some convective currents going on, you got some conduction. So it's much more interesting to actually implement in real life. Second thing on the list is airflow. Hardly anyone truly understands airflow and pressure, and they're 2 sides of the same coin. Where there is a pressure difference, you can be sure there is going to be flow, and where there is a flow, you can be sure that there's going to be a pressure difference, right? So that's one thing that the blower door is really excellent at as the king of the tools in our tool chest. So that's the second thing on the list. Now, at that point, we have ended the discussion about energy efficiency, right? The last 2 things on the list, which, again, this is in increasing order of importance, have nothing to do with energy efficiency. That's why you are not energy efficiency experts. You are home performance experts. And you get paid accordingly, because you are not just an expert in heat flow and airflow, right? You're an expert also in moisture and air quality. And that makes you much more valuable. So don't limit yourself to just being an energy efficiency advisor or an I save you energy or things like that. It really doesn't sell many jobs. 2 of my colleagues are here in the room, and I would say that 99% of the clients that we get on both the existing home and on the new construction side come from asking us to solve their what kind of problem. Anybody have the same type of clients? What kind of problems do people want to solve? Anybody? Moisture, some people said. Anybody else? Comfort. Comfort. Number 1, right? I'm married. How many guys in here are married? Right? What is your number 1 goal in life? Make sure she is not unhappy, right? Because if she's unhappy, you're going to know it. And so, I spend a lot of time thinking about how exactly to make my wife happy so that she's peaceful, and I can be like, all right, great, everything's fine, right? Happy wife, happy life. That's something that I learned a long time ago. So the moisture and the air quality.
She's here, right?
No, I don't. I say that in every. She is in the room, but I say that all the time. It is a big deal. We get calls from husbands whose wives have told them to call us, right? Or from the wife themselves. But the woman is generally more sensitive. If a guy's living by himself, we'll put an extra blanket on or put on a sweater, right? We don't care. So it's the comfort stuff is really, really big deal. Once you get kids into that mix, the air quality becomes a much bigger deal. And the air quality is closely linked with moisture. So again, increasing importance. The least 2 important things on this list have to do with the energy efficiency. Everything else on this list is the stuff that we really need to pay attention to. Okay, so quickly, this is from Joe Seabrook. Everybody know who Joe Seabrook is, right? And his partner, John Straub. And by the way, I'm going to make a little plug real quick. This is my new book. It's called Home Performance Diagnostics, The Guide to Advanced Testing. John Straub, Seabrook's partner, wrote the foreword to this book. It's out in our booth. Please feel free to visit it, and you can just feel free to look through it. But it's going to go over a lot of the principles and a lot of the tests that deal with this stuff. So his idea for the 4 reasons why this field is not a fad. It's not going to go away tomorrow. It's not just another way to get a buck out of a homeowner, is because we need to be doing this analysis because we've been building houses differently than we ever did before, right? So we've got insulation that we've been doing since World War II. Plastics going into houses. What kind of plastics do we put in houses? Vinyl. Carpets. Okay, cool. Polyurethane spray foams, polyethylene vapor barriers, stuff like that, right? That all goes into the house. Maybe it's controlling in a way that we mean it to, and maybe it's not. Particle board, forced air systems, right? All of these things have their associated problems that come with them, right? Insulation, I like to joke, gives you a false sense of security. Everybody feels like, oh yeah, I got more insulation, I'm happy. Plastics, though, inhibit moisture movement. Maybe we mean that. Maybe we don't. Particle boards don't take moisture very well, and forced air systems introduce pressure imbalances in the house. By the way, getting back to this, if you want a definition of a high-performance home, anybody wants just to be able to say it in one sentence, the definition of a high-performance home is one that controls every one of these aspects. If you've got that, you're done, right? So the goal is control over these systems. That is why it's not about the energy efficiency, right? At some point, how many people in here are BPI certified? Great, okay. What's that magic equilibrium between air tightness and air quality called on that blower door scale? Anybody know? The building airflow standard. Everybody says building airflow standard, 0.35 times volume divided by 60, right? So there's math. That's good to know. So it's solid. We can lean on it. That rule to a lot of weatherization programs, and what is the goal of a weatherization assistance program? Energy, what? Reduce the energy. Bam, that is their number one goal, right? Least two important things on my list. Their goal is to get you right down to that equilibrium, okay? So you're controlling a lot of the air leakage, and you're controlling a lot of the heat flow, but not all of it. And if you wanted to truly get high performance and really be able to both get the benefit for your clients, make them feel like, man, my house is awesome. I have a Mercedes. I'm going to invite over all my friends, tell them about this person who helped me solve all my issues. Then you got to go all the way down to the ultimate control of that stuff. So don't stop air sealing when you've hit the building airflow standard, right? Keep on air sealing. Let's ventilate. Make sure that we've controlled the air quality, the airflow, all the heat flow, and everything like that. So don't stop at just the energy savings, because that is only half of the picture. So we're going on past here. A real quick review. Everybody probably knows this. 20% of the energy used in this country goes into homes. Half of that energy goes into heating and cooling systems, right? So the people who are out there doing just this portion, the lights and appliances, they come into the house with a checklist. And I'm sure that all of us might have started at that point, just going in and kind of doing an eyeball assessment of it. We're only hitting 25% of the problem, right? And maybe we can reduce it from 25% to 20%. That would be cool. That's a 20% reduction in that aspect of it. But if we don't hit the heating and cooling loads, then we're not getting it at all. And for any utility program out there that is not a whole home program, that's a major deficiency in that program, is that they're not taking advantage of the single biggest opportunity in the home. Okay, so just real quick to explain so that we can get into the infrared portion. I'm going to be explaining a lot of things through the lens of infrared. You don't have to be using infrared in order to understand what I'm talking about. You also this is not going to be dependent on infrared. You don't have to use infrared to study home performance, obviously. In fact, I want to make perfectly clear this is not the most important tool in the kit. It's just the sexiest. That's all. So just to go over this, infrared is not an X-ray, right? It is a visual representation of the amount of heat that's radiating off of surfaces. So we could look at everyone in this room and do an analysis of who's got a fever in here. Who has a fever? No one raised their hand. Good. Okay, so we're going to see this heat of solids, of the walls and the drywall and the surface of the tablecloths and all that stuff. You can't see through things, right? So don't watch the ghost shows or whatever it is that they're doing on the TV and think that it's for real. The camera is a tool, just like every other tool, including math. It can be used for the power of good or for the power of evil. Your job is to not do this if you're going to use infrared, just like if you're not going to use a blower door. You don't use a blower door and tell people, oh, your ACH at 50 is a 3.25, and then collect your money and go away, because what are they going to do with that information? Nothing. They're not going to do anything with it. They're going to think that you're, too technical for words, and they're going to think, oh, I don't want to have anything to do with home performance. That sounds really yucky. So don't take pictures like this if you are going to use infrared, because it doesn't help anyone. The point of infrared, who are we helping when we use infrared? What's that? Or yourselves. It can help you do your job faster and easier, but the main thing that you buy a $4,000 infrared camera for is you want to impress your client and you want to get the point across, right? I use my infrared images, not really for myself. I use them to convince my client to do what I want them to do. So I take pictures to that effect. Okay, so quickly, when you're going to do this whole home performance analysis, you could do it at any point of the year. It does not matter if it's 70 degrees outside and 70 degrees inside. So please don't let anyone tell you that you can't do a blower door test or an insulation inspection or an infrared scan on a 70-degree day. That's total BS, and I won't have it. So that is going to keep our industry seasonal, and that's not what we want. You can do this stuff all year round if you've got good equipment, and there's lots of examples of good equipment out on the trade show floor. I hope that you will go and talk to those people about what specs their camera has. I'm happy to talk to you about what I use in my own company, but a 3-degree temperature difference is all you need to do a really thorough air leakage job, and air leakage can also show you insulation deficiency, and those are the two main things that we're going to be looking at as far as the opportunity for improvement. 3 degrees can be very easily created using what? If it's 70 degrees outside, 70 degrees inside, bam, I kick on the heating system for an hour and a half, and I'm done. Okay? So anything, air conditioning system, if I've got one, then that's great too. I could use that instead. Was there a question over here? Great. Okay, bam. Again, most important tool is the, what is that? Blower door. Thank you. You guys are so quiet. You can talk to me. It's okay. All right. So when we do infrared scan, just to be perfectly clear, a lot of the pictures that you're going to see are in conjunction with the blower door. Please don't go out and use infrared by itself without a blower door and think that you're doing a really thorough job. You should be very clear with your client that, okay, you know what, since you can only pay me $300, I'm happy to do some stuff for you, but really you should be investing in the full thing, which involves the blower door testing and all that stuff. That's the best. So I'm not really giving you the full picture at this point, but I can give you some opinions with some colorful pictures, and that's important. All right, your opportunities for improvement are thus. Number one, opportunity for improvement, and Mark LaLiberte said it earlier this morning, air sealing. That's gold, right? You do that, period, no matter what, in any climate. Number two is insulation. The reason that air sealing comes before insulation is because which one wins in a battle? Air sealing. If air moves through insulation, it's like the insulation isn't there, right? So you got to get the air sealing first. That's the most important thing. After the insulation comes the mechanical systems. How expensive is it to do air sealing and insulation? Do we have insulation contractors in the room? Yeah? Is it expensive to do air sealing and insulation? Okay, how much does a new furnace cost? $3,500. How much does it cost to do air seal and insulate an entire house? A couple grand, right? So we're talking about a furnace that's like this big that will die in 15 or 20 years versus an entire house of air sealing. You never have to maintain it. You never have to replace it. It's super cheap, and it's cheap labor, right? So those beat it every time. Also, what does it cost to run a furnace versus what does it cost to run air sealing, right? You don't run air sealing or insulation. They're passive measures. They come first, always. The mechanical systems should always follow the passive measures. So anybody who's a heating contractor in here, if you just go in and replace the furnace or the air conditioner, you are missing out on a huge opportunity for your own revenue. And you have to take that seriously. That is why heating contractors will come and get BPI certified and learn how to do envelope testing. Is because you can then go out and start subcontracting the air sealing and insulation, give your client a slightly less expensive piece of HVAC equipment, making you look like the good guy, and you made them more comfortable, and you made sure that the envelope stuff is not going to screw up your highly calibrated piece of equipment that you just installed in their house. Okay? So after the mechanical systems comes the stuff that people think is the most important, right? So we'll get the behavioral stuff. Oh, I'll turn down my water heater and I'll take less showers, or I'll like line dry my clothes, or I'll not open the refrigerator as much. Behavioral stuff is really going to make some difference, but it's really hard to manage that. And then renewables, right? Your client's going to call and they're going to say, I want a wind farm on my roof or a solar panel or something like that. That's the last thing you ever really want to recommend. So air seal and insulation make up what's called the what in the house. It's the most important component of the house. It's made of a pressure boundary and a thermal boundary. It's called the envelope. Yes, say it loud and proud, guys. That's the most important thing, right? So the envelope is what we're talking about. I had one lead who came to our company, and she said, envelope? That sounds like spin. I've never heard that before. And I was like, okay, I don't know what to tell you, but it's a real thing. So we should all be using that word, and we all know what it means. All right, so number one priority is air sealing, right? Within air sealing, you always start at the top of the house. We'll talk about why in a second. That's always the first goal. That's generally the last place you want to be working. How come? Anybody been in an attic? Yeah, you? Oh, nice. Good. You're getting a little ahead of me. Get up here and start teaching this class. All right, so heat rises. We're going to talk about that in a minute. Why do you not want to hang out in an attic? Because it's disgusting. It's hot. There's like raccoon poop, maybe. You know, there's all kinds of gross stuff in an attic. Who wants to hang out in an attic? How many people in here? No one. All right? But that's where we got to be doing the work. Generally, somebody who is not really cognizant of what is going on in the entire home as a system approach will go down to the basement and seal the rim joist, right? How many air sealing companies do you know of that will just go into a house and just seal and insulate the rim joist in a house, right? It's not really hitting it, and I'll tell you why in a second. Next thing you want to hit is the rim joist in the basement or anything else that's low in the envelope. And then, and only then, everything in between. A lot of times, your clients are going to get you on the phone, and they're going to say, so you're going to use an infrared camera, right, for example, since we're talking about infrared. Are you going to show me where all the leaks are in my doors and windows? Right? Has anybody gotten that question before? Yeah, that's what they expect you to come in and show them, is all the leaks in their doors and windows. And could you do that? Absolutely, yeah. Do doors and windows leak? Yeah, sure they do. Yeah, I'll go in there, I'll take your money, and I'll show you all the leaks in your doors and windows. That's generally what you do when you're at the beginning of this type of a career. That is the number one, it's number 3 on the list, right? Number 2, it's really what they expect. When you can start blowing them away with stuff that they had no idea even existed in their house, like if you show them what a top plate is, wow, amazing. So that's the priority. Now here's the thing. Everybody's seen this image, right? It's from the Department of Energy. Heat rises. That's actually a misnomer. Hot air rises. Heat travels from hot to cold. Yes, good. Heat travels from a hotter thing to a colder thing. So the hotter something is next to something that's colder, the more heat flow there's going to be. When your house is 60 degrees and the outside is 90 degrees, there's a fair amount of heat flow trying to come into the house, right? First of all, you shouldn't keep your air conditioner down at 60 degrees. Tell your wife not to do that. Secondly, when you're at a 0 degree outside temperature and the inside of the house is at 80 degrees, right? You know, some weatherization projects that you might walk into, there's a ton of heat flow coming in. So the difference in temperature, which is also called the, anybody know? It's a Greek thing. Yeah, delta T, right? So if you want to sound technical, don't talk about delta T with your clients. Talk about it with other contractors where you're trying to intimidate them with how much you know. So the delta T is the key in this heat, in this stack effect is what it's called. Hot air rises, right? So first thing that happens is we heat air up inside the houses 9 months out of our year in this climate. Okay, the second thing that happens, and by the way, this sequential thinking is one of the key differences between you guys and all the other contractors out there that are not doing this. You are able to think both in terms of interactions on like a one plane. How many people are musicians in here, by the way? Anybody play music? Okay, cool. This is one of the things that musicians can do. They can look at the relationship between notes that happen at the same time and the notes over time, right? So that's kind of one of the skills that we're talking about. Thinking sequentially, one thing happens. We heat air up inside the house. That warm air now goes up. It all collects at the top of the house and has a party up there. Meanwhile, there's hardly any party down at the bottom of the house. So it's a low pressure system at the bottom, high pressure system at the top. So now we have this pressure differential, and the pressure outside hasn't changed at all. You can't really change the pressure outside. That's wind and weather and stuff like that. Okay? So once that happens, air is trying to get up into the attic and out through the top of the house. And does it? Yeah. What do we put up in the top of the house? All the crap. Yep, all the crap goes up at the top. So we got all the duct work. Of course, that's in the attic. We got exhaust fan terminals. We got top plates. We got chimney, blah, 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 all that stuff, right? So there's tons and tons of holes at the top of the house. When air escapes into the attic, then the house needs air, and it sucks in actively at the bottom of the house. So the key is if you get, whoa, what happened to that? You guys didn't warn me. I've been pressing buttons. If you get one of these snakes, and I think Keith Williams uses that term, if you get one of these snakes, you get one of these snakes for free, right? You do air sealing in the attic, you get a 2-for-1. You stop air from escaping the house, and you stop the house from sucking in more cold air from outside. So double your money. And by the way, you're only going to reduce the CFM when you do a blower door for the 1, but you get the 2 for free, right? It's like buy 1, get 1 free kind of thing. It's not going to show up on the blower door, but you will in fact be helping that. Just like a hot air balloon, right? Think about a hot air balloon. You could look up at the bottom. There's a big hole in the bottom. but you don't care because the top is all sealed and there's no way for the air to get out. In the summertime, it reverses, and it's called reverse stack effect. You cool the air down, it sinks through the house, right? At that point, the top floor is going to get warm and moist because it's sucking air in from the attic. Okay, so here's an example of all the stuff that we put into the remodels or the new construction or whatever it is. Hopefully these are all what kind of fixtures? Airtight, insulation contact, airtight, ICAT, or airtight with a TITE, however you buy them. That is what they'll look like from the top. That is an IC rated light. That's what most architects, any architects in the room? No? Okay. Most architects are using IC rated, not ICAT. They don't know, they're not thinking about the terms of the air leakage. And the reason that we really care about air leakage at the top of the house is because of the phenomenon called stack effect. Thank you. Good. Okay, so the stack effect is the #1 driver for pressure in the house because it's 24 hours a day, every minute of the day, constantly. The air is pushing, right? Grand Canyon was made just by water dripping over millions of years, right? And it curved out this huge thing. This is the Grand Canyon of the house, is this stack effect. Okay, there's your top plates. Don't forget about the top plates. This is another thing that's in the top of the house. Most people don't even think about it. But at the top of any interior wall, which is studs, there's a stud that lays at the top. It's called a top plate, right? The edges of this thing have drywall coming up next to it. And this is even a kind of an interesting looking one. This might be a plumbing wall, right? Which is another thing that's an extra wide interior wall. These are literally dozens of feet of just cracks, right? That go throughout the entire top of the house. They all need to be sealed. That's what it looks like under infrared when you run a what in conjunction with your infrared scan? Blower door, bam, you got to run it. In fact, if you go out and you try to find this kind of thing without a blower door, will you see it? No, you won't, because what pressure is it at the top of the house? It's high pressure in relation to the attic. So there's always air leaving through the top of the house. If you have clients who think they feel drafts on the top floor of a house, that's got to be a majorly bad situation because generally on the top floor, where their bedrooms are, there's going to be air leaving the envelope and they won't really feel drafts. They'll think, oh, no, it's my basement that's really the problem, not my top floor. The top floor is fine. Really, the top floor is not fine. It's just all the air is leaving the house there, coming into the basement. Now, let's think about this for a second. Homeowner feels cold in that scenario in which room in the house? In the basement. Right? So what do? If we let them self-prescribe their solution to their problem, what do they want to fix? The basement. Okay, so they hire a contractor. They hire Joe to come out and they say, Joe, I want you to air seal and insulate my basement. And I know that air sealing is important because I heard it at a presentation. So Joe says, okay. He says, yes, yeah, thank you for the work. Yes, I'd be happy to. And he does a bang-up job, right? Air seals and insulates the heck out of that basement. Now, is there air still leaving the house? Yes. Does air have to be sucked into the house in order to replace that? Yes. Now where are they uncomfortable? On the first floor, right? We've just moved it up. Now the house can't take it in from the basement. Fine, I'll take it in their living room. Now, are they more comfortable or less comfortable? Yeah. Now Joe is going to have to pay for free work to fix their problem, or he's going to come back and rip all that stuff out, and it's a big problem, and it wasn't his fault. He just didn't understand that it's not the basement, it's the attic. That's the problem. It makes no sense to a homeowner unless you start explaining it. Here's another example, right? We got the plumbing wall and the major air leakage and insulation deficiency. Can we stop doing this? Yes, good. Okay. This is actually the attic. This is one of my favorite attics in my entire career. It's the attic of a very high-profile public figure in our state of Illinois. And I went up in her attic, and she's got like the most amazing, what we like to call opportunities for improvement, right? Because they're not problems, they're opportunities. The worse the house is to begin with, the better they're happier they're gonna be when you're done, right? So we found like basically a catalog of every problem that you could possibly find in an attic inside of her attic. There's all kinds of stuff that we could talk about here. But basically, once you put HVAC in the attic, where is the envelope of my house now? Right? It is those ducts. Those ducts are now the furthest thing up and outside the attic. That means that they need to be as insulated as possible from my envelope, and they need to be super airtight because there's constantly a high pressure system pushing on those bad boys. Okay, so that's not really the best situation. You'll see this kind of thing. Now, if you run your analysis, if you're doing a whole home analysis, and since we're all professionals in here for the most part, I would say that that's how we're going to be approaching this. Then you run it generally in a combustion testing first, blower order test second order. Does everybody generally do that? Yeah? Okay. Did anybody do it backwards? It's not backwards. It's just the other way around. I have a close colleague who does it the other way around. They do the blower order test first and then the combustion testing last. I prefer it this way because when you run the furnace, we ran the furnace for the combustion testing literally 10 minutes ago. Now I'm running the blower order test. Why on earth would there be cold air coming in my ductwork where the furnace was just running? I know for a fact that it was 130 degrees inside that ductwork 10 minutes ago. So now that it's cold, I've just identified duct leakage, right? And that's one of the major problems up at the top of the house. It's at the top, and we got to air seal it. Okay? When you see things like this, where the homeowner has fixed something, or not even the homeowner, but any contractor who doesn't really understand the whole home as a system thing, we'll have somebody say, as they're giving us the little tour of the house and explaining, oh, we had pipes freeze over here, and this happened over here, and my daughter's room is cold. Oh, and by the way, the roofer is coming tomorrow to fix our roof leak for the 5th year in a row. Oh, that's an expensive problem. If there's anything you want me to tell him, just let me know. And I say, great. And I write down, cancel the roofer, because it's not a roof leak. 99% of the time, it's what? Anybody know? It's moisture condensation, right? From what? Warm air hitting cold surfaces in the attic and then running back down, right? So the solution to this is not to put an entire laundry basket full of towels around this pipe to stop the roof leak from getting down there. The solution is air sealing, #1 opportunity for improvement. Wonderful. Okay, ice dams, right? Go to Home Depot. You tell them you have ice dams. What are they going to sell you?
Shield.
They're going to sell you a what?
A roof shield.
Yeah, which is what? Who said that?
It's an air seal. It's just aluminum foil and tar paper over it.
Probably to sell insulation.
You need to give that guy a spanking. What? Heat tape. Yep, good. They'll give you a little wire that plugs into the wall, and it warms up your eaves to make sure that the ice melts off of your eaves too. That is a Band-Aid. That's not for real. So the solution is to hire you to come out and do a really excellent air sealing job inside the attic, right? And this is the kind of thing that we're talking about around the chimney. And by the way, you'd want to, obviously, is because it's a chimney, use fire-safe baffling around this, like that. Bingo. Okay, then we go down to the bottom of the house. We got the rim joist. Rim joist is a big problem because it's a flat board that's at the edge of the floor cavity, and it's resting on top of a flat foundation wall underneath a flat floor, and they're butting up end to end, and none of that stuff really works out too well in real life. The sill gasket that they use, by the way, it doesn't really work for air sealing, unfortunately. Okay, it might result in a problem that looks like this. And if you're a beginner energy auditor, what you would say is, let's caulk all those baseboards. In fact, there are 2 types of fixes as far as air sealing goes. There are point fixes and source fixes. A point fix is one that is not going to reduce the air leakage number on the blower door, right? So it just fixes where the air that's inside the building assembly comes out of the building assembly and into the living space. So this would be a point fix if we caulked the baseboard. It would keep the cold air from coming out of the wall cavity and onto our feet. That is perfectly acceptable. You should do it, because making my wife happy is the most important thing. And if her feet are cold, I'm going to know it. So I got to fix that, right? So that's fine. But what would be better is a source fix, which means fixing it before it even comes into the wall assembly, because we just don't want it in the wall assembly. That would be better. Okay, so that, going back, oh my gosh, what is my problem? Holy crap. Somebody let me know when that happens. I just did it? Okay, well, I got to hold this thing a little bit more carefully. Okay, so when it looks like that, what that is really a problem with is the what behind it? Rim joist. Okay, so when you go down to the basement, you see the rim joist is leaking. When you fix the rim joist, you fix that automatically, 2 for 1. And again, nope, okay, good. Plaster walls. If I can see this much plaster and that much plaster and that much wood, and I can see the subtle variations in the thermodynamic properties of those 2 materials next to each other, is there really that much insulation behind all of it? Right? And I want that much insulation behind everything. I want this much insulation if I can get it. But really, it would be nice if walls were insulated. You can also see the air leakage out of that fixture right there. New walls are no different than old walls, right? Except that they're a little less fixable, unfortunately. So the bad news in this case is, client, there's something in your walls, right? So what can't we do, most likely? put more stuff in there because there's already some stuff in there. What is the main ingredient in insulation? Insulation contractors? Air. Air is the main ingredient in insulation, not fiberglass or cellulose, right? So if you squish more stuff into that wall, it's just going to make it less insulating. It might fix some of the air leakage problems and the deficiencies, but really it's going to be not a great bang for your buck. Okay? So doors, everybody knows, yeah, doors leak. But remembering that they don't just leak where they open and close, and the weather stripping should be installed, and yeah, that's a good thing to do. And if you're going to use it, don't use peel and stick, use something that's mechanically fastened. But also around the outside of the frame, right? And that's an important thing that the client would never know unless you used your highly tuned skills to pinpoint it. Okay, and the same thing with windows, right? The window itself is not the problem here so much. Number one, do you feel a draft around every single window in the universe? Yes. If you read your residential energy textbook, right, there's this convective loop that happens around windows. The air in contact with the window cools down. What happens to dense, cool air? Sinks. So somebody who's sitting underneath the window thinks there's air coming from outside when in fact it's just the air that's in contact with the window, right? Okay, number two opportunity for improvement is insulation. Okay, so after we've hit all the air sealing, we hit the insulation. This is one of our students who's just sends back to that wall. So there's math, right? And you guys are all professionals. You should know that there is math. You don't have to know how to do that necessarily unless you're an insulation contractor, in which case you should definitely understand that. What the math says is that it's all good as long as it's done right, right? So looking at the case study, this is something that I share with every one of my clients on the home side. I come up with just a real simple analogy for them. I say, okay, let's imagine that you have a 1,000 square foot attic, and 99% of it, 990 square feet, is insulated perfectly to R38, which is the code currently in our state. 1% of it, 10 square feet, got forgotten about. Oh, we forgot to insulate that. Can anybody think of an attic where that would be the case? Yeah? Every attic, right? What is that 10 square feet? It's the attic hatch or the attic ladder, okay? Got forgotten about. So here's what happens when we insulate 99% perfectly, but 1% didn't get done, right? It takes it from an R38 to an R28. So you get a 25 to 30% reduction in the overall average R value, it's called the assembly R value, for that 1% reduction. That is why everyone in this room should be convincing your clients to pay full price for 100% perfect. 99% perfect is no good at all. They just wasted. You give them a quote for $10,500 for insulating the attic and the walls and the basement and all this stuff. Somebody else comes back and gives them a $500 discount for $10,000, and they're like, I'm going to get it 99% perfect, don't worry, right? They need to be paying you guys full price, what you're worth, to air seal and insulate properly, 100% perfect, okay? And I make a point of telling every single homeowner group that I present to that exact fact. Discounts don't get you anything, right? So it's a personal policy in our company. We try not to give discounts like ever because it just gives the wrong message. Charge what you're worth. Okay. Here's that same house of that really great public official who was awesome. She was so nice. Here's what she looks at, right? And here's what you can see with your own eyes. So that's a lot worse than 1%, right? This is infrared. I said your own eyes. So is that more than 1%? Yes. Would you say that that's essentially an uninsulated bathroom ceiling? What's the most important ceiling in the house to insulate? The bathroom ceiling. Why? What's special about the bathroom? It's moist. Right? So then we get back into that aspect thing and thinking about heat flow and airflow and moisture, air quality. Really, it's all one thing. We just break it up into 4 things so that we can think about it clearly. Okay, so the bathroom is the last place you would want this to happen. Now, luckily, her house is super drafty, so she would never notice a moisture problem in this bathroom because she's got all kinds of stuff that's taking the moist air out that's not the exhaust fans that don't really work in her bathroom. So as soon as we start doing good stuff to this house, what's going to happen? Yeah, and it's going to get worse. As soon as we start fixing anything in a house on a home performance basis, we make the house more dangerous. Okay, so that is another reason why you get paid full price for doing something that is highly sophisticated. Don't leave this up to people who are not certified, who have not been formally trained. Okay, this is really dangerous stuff. So if you do a good job with this house, you could potentially be called back or be sued or whatever because you're going to make stuff worse. And that, as houses get tighter with new codes and everything, it's going to get more and more obvious that contractors have to be super smart about this. Okay, bam, so that's my message. Heat flows from hot to cold, right? So when we go back to the air, the HVAC in the attic, the hotter something is next to something that's cold, the more heat flow there is. Now think about this. Do we generally insulate the house envelope or the ducts in the attic? Most people would think, oh, I want to insulate the house, right? That's where I'm living, not the ducts. Think about this. What temperature is it on a 20-degree day outside? What temperature do we want it to be in the attic? 20, right? If it's any warmer than that, it means it's more part of the house, and we don't want that. So in the attic, it's 20, okay? The house itself on the inside is 70, let's say. That's a 50-degree delta T, right? What temperature is it inside the ductwork of this heating system? Yeah, in this picture. Now, if we got into a full discussion of infrared, really it's not 114% because of the emissivity of this material that we're shooting, but it's probably about 130 degrees, right? There's roughly a 60-degree heat rise on this system. So there's going to be 130-degree temperatures in the ducts and 20 degrees, right? That is a temperature differential of 110 degrees, right? 20 degrees in the attic, 130 in the ducts. Now, which one do we care about insulating? The house with a 50-degree delta T or the ducts with a 110-degree delta T? Way more heat flow out of the ducts than out of the house if you think about it in a really simplistic way, right? So that's another thing that we're just like, man, not really paying attention sometimes when we've done work like this. And it'll result in that kind of thing, right? So in summer season, you'll see brand new houses. We get called out to houses that haven't even been lived in yet, and they've got little stains around the drywall of the ceiling registers, right? That's because cold air travels through the ducts when the air conditioner's on. It's going to be about 55 degrees on that metal at the boot. The boot is uninsulated because it's not important to insulate the boot. Who cares about that, right? And hot, moist, 130-degree attic air is in contact with that boot. It condenses, stains your drywall, rots out your register covers, right? So all this stuff, it's really what somebody who's not thinking clearly would do is replace the register cover, right? Somebody who's like you is going to go out there and actually fix the problem and take full advantage of the opportunity for improvement and then tell your client what exactly you did and why it was important. Because, oh, and by the way, this is a really great thing. Gord Cook, who is another instructor for EBA, just like Marc Laliberté, has this presentation that he does. I want to check on what time it is real quick. Okay, great. On selling, right? And it's really important to educate your homeowners. Do homeowners want to be educated? Yes, they do. They love it. The reason you're going to get the job over the other guy is that you are the one that told them more about their house and they feel more like, wow, I didn't understand that before. So you're the one that's going to get that job. They only want 7 to 10 minutes worth of information though, right? So you got to really know exactly how to talk about this with your homeowners. So feel free, practice talking about this stuff with your families, with your friends and all that stuff. The better you get at talking about it, the more you can customize it when you have 3 minutes of a person's time to really get them hooked and want to hire you. Okay, now also heat flow, right? We got 70 inside the house, 20 outside, same day, 50-degree delta T right there. In this radiator, and this radiator is off, right? So let's think about it when it's on. It's 160 degrees, let's say, when it's in, early in its cycle. 160 degrees versus 70 degrees is 110-degree delta T to the inside, right? So the radiator wants to give its heat to the inside, but it wants even more badly to give its heat to the outside because outside there's the 160-degree temperature and there's a 20-degree. That's 140-degree delta T. That's much more than to the inside, right? So it's going to want to go straight out that uninsulated wall behind it. That's why it's really important also to then make sure that the walls are insulated for the equipment efficiency. Okay, and pipes, right? Do we insulate pipes in conditioned space? Does anybody do that right now? Anybody in the room? Okay. Here's my argument for why you should be doing it. Heat flow, right? Hot to cold. Inside these pipes, it's 160 degrees because this homeowner has it turned way up. So the heat flow from the pipes to the space, and we're talking about a domestic hot water system, right? The drinking water, the shower water, all that stuff. What is that system for? What is the function of your water heater? What is it? Heat your water so that it comes out of the faucet or the shower head at the right temperature, right? Did you design the water heating system so that it would heat your space? No. And for the reason that I explained at the beginning, the goal is control, right? If I'm using a system that's not designed for this thing over here to just, oh, yeah, well, you know, it's all one thing, right? As Mark would say, there's a guy who's going to like fix that at some point. There's not. It's you. So that's why I always recommend insulating all pipes, all ducts, even if they're in conditioned space, because if I'm going to engineer this system really carefully, I want the water or the air to go where I wanted it to go, right? That's ultimate control over the system, right? Think about it as your body, right? If you've got uncontrolled events going on inside your body, particularly in your, intestinal system, that's really uncomfortable, right? Who wants that? No one. So we take lots and lots of steps to make sure that never happens inside our body, but we don't pay attention to our houses the same way. Okay, windows. Any window people in here? You can raise your hand. It's okay. Okay. I love windows. I actually really like, so Sirius Windows has some really good R values on their windows. Here's what I'm going to say. Single pane window is an R1. Double pane window is an R2. That is 100% better, but if you think about it in a systems kind of a way, then you realize that the wall insulation that we want is R19, right, for code. If we have a difference between an R1 and an R2 when we spend $20,000 replacing windows in the house to go from an R1 to an R2, when we really want an R19, it's a drop in the bucket. We haven't really done anything at that point. Any building that's LEED certified, right, would be at which end of this spectrum? Way down there, right? We got all these LEED certified high-rises in Chicago, and they all are nonstop windows, and they all are basically completely uninsulated, which pisses me off, and that's a technical term. So we're just looking at the fact that, again, heat flow is nonlinear, right? Now we get to the third opportunity for improvement. I'm about to finish up. Mechanical systems. Once we've done the air sealant installation, and only then do we look at the mechanical systems. Mechanical systems want to control each of these individual components inside the system. We've got the heat transfer system. In the furnace, that is the heat exchanger. In a water heater, it's the heat exchanger inside the tube, right? In the AC coils, and et cetera, we want to make sure that all that stuff is controlled, that there is insulation where it's supposed to be, and where there's no insulation where it's not supposed to be. Where would you not want any insulation in a mechanical system? Around, let's say, outside on the condenser coil of the air conditioner. Did you know that dust actually has a really huge impact on heat transfer? The whole goal of the air conditioning coils is to give heat off to the outside or to soak it in from the inside. And anytime you've got dust on it, it's an insulator. All right, good, thank you. So distribution systems, right? This is a really beautiful picture, isn't it? Isn't that amazing? Somebody designed that, and they like put it together, and they did all this stuff, and there's no pipe insulation. Okay, and then the control systems, making sure they're put in the right place and that they have the right labels on them, et cetera, et cetera. We want to make sure that if we can, we go for sealed combustion. That removes the combustion process from the air inside the house completely. That's very safe, and that's important for the air quality because carbon monoxide is deadly. And that's all I'll say about that. I'm going to go for Energy Star if we can, and then if you're going to do an improvement analysis, the only way to do it is with an energy model. And that is why a system like the federal government system or like a utility system that rebates for individual pieces of equipment makes how much sense? None! Thank you. Who said that? I like you. All right, good. It makes no sense. All right, you take an 80% furnace, you replace it with a 90% furnace, you've totally orphaned your water heater over here, and you plugged it into a duct system that's 50% efficient. What difference did we just make with all that taxpayer money that we just spent on that? Absolutely none is the answer, okay? That's stupid. All right, here's another issue. This looks perfectly fine, right? We got the right pitch, and actually that looks a little flat, but it is going up. But we've got a 3-inch and a 3-inch going into a 3-inch up here. And it's a T junction instead of a Y junction. And you don't have to be a heating contractor to understand that when you run the testing on this, which is certified by BPI, right, it's standardized. When you run the test on this, you would understand what the problem is. That's why it's really important to do the testing. Also, make sure that you're just showing your clients what they would never think is the problem. They're going to ask you over to their house to find the leaks in the windows so they can get an excuse to replace the windows, and to find the weather stripping problems with the doors so that they can do that themselves next Saturday. Okay, that's really not what you're there for. You're there to upsell them on all the cool things that you could possibly do. So, standardized testing, important, right? There's an argument that somebody who's done this for 50 years would make. They would say, somebody who's been through BPI class for 6 days doesn't necessarily know anything. And I completely agree. But somebody who's done it for 50 years the wrong way might also not necessarily know anything, okay? The reason that this is important is because even if you have been only through 6 days of class and you got that certification, what it means is you know how to do something that has been standardized by people who are brilliant at this, okay? I'm not concerned about rewriting the standards. The standards have already been written. I'm going to take what those brilliant research guys have done, and I'm going to use it on every single house the exact same way, and what the promise is that it will work and that I will come out with good results. Okay, so if you're not BPI certified, you should certainly consider doing so, because it's really a mark that says, I know how to do things the same way the next guy does them. So if he did it supposedly the same way I did it, and I get different numbers, I could call him out on it, right? Otherwise, we're all just kind of floundering. Also, for the HVAC guys in the room, we go around making a lot of money finding problems that HVAC companies have let linger, right? Because number one, hardly any HVAC companies actually do testing, right? They'll come out and clean and calibrate stuff like that, but they don't do combustion testing. We hardly ever find drilled holes in any combustion equipment. And secondly, they're not used to anybody looking over their shoulders. So this is really important that we all know that people are looking over our shoulders and we're being watched by each other. Because that is how this quality assurance works, is that it's a market-based quality assurance. Was there a question back here? Yeah, what'd you say? Most classes are 6 days. And then that's like a college course stuffed into 6 days. So it's very, very intense. I talk fast like this the entire time. So we do all the risk management, and that is the number one key, right? Risk management is not about the energy savings. It's about finding the control and making sure that doesn't happen in the house while the homeowner is there. We can do the improvement verification. So you can say, you know what, homeowner, I'm going to do this for you, and I'm going to prove to you that I did it for you, because we have very clear objectives. Here is what we're going to do. Here is the goal at the end of when we're done. We're going to take you from this situation to this situation, and we'll be able to show you the data that says that we got you there. That sounds awesome, right? They get to actually trust you because they're trusting the actual findings that you have. Okay, and again, this book is out at our booth. Feel free to go look at it. It explains a lot of the diagnostics that would be needed. Thank you very much. Any questions?
How much is the book?
Oh, the book is $99, by the way. Don't go and pick one up and walk away. Thank you. Yes?
As far as combustion safety first,